Thank you very much. God bless you and God bless the day. Nigeria is going to be great. Today, our latest cohort are taking the last part of the course, that is IoT and embedded systems, and I decided to share it with you. For detailed curriculum, because time will not permit us to be able to do that, you can go to our website www.nasconsoft.com. Just click under IoT. You are going to see the course details there. So going briefly, IoT is just Internet of Things or Internet of Everything. And as embedded system engineer, our main concern now is on some part of the component, that is the device part, the networking part, the security part, and the user interface part. That is what we are actually mostly concerned on. I want to talk about the device. That's starting from the microcontroller, because that's where the processing starts from. You have your sensors that are attached to your controllers. This will pick physical parameter or any other parameter and send it to the controller. The controller will now process it. Because you want to be able to monitor it or control it remotely, you will now need a network device, that's a Wi-Fi module, the one that will help you pick the information from the microcontroller and take it straight to the internet. That's the internet. That's the concept now. From your sensors or your actuators or your sensor actuator or your modules, you are sending to your controller. The controller will now pick and send from the Wi-Fi module. Wi-Fi module now is to now go straight to the internet. And from the internet now, the next thing is just the user interface. That's the UI. So what are we actually interested here as embedded system engineer is that how do we pick this information from here, send it to the microcontroller, of which we know here now we have two things. One, some of the controller now have internal ADC and DAC. DAC means analog to digital converter. ADC means digital to analog converter. A controller like Arduino actually has that. That's why we don't need to stress ourselves trying to do this manually or using the code. But a controller like the Raspberry Pi, this is Pi 4, this Raspberry Pi now doesn't have analog input. So anytime you're working with it, you need an analog to digital converter or digital to analog converter, depending on either you're bringing in or you're taking out the analog signal from the device. So because of that now, this is what is going to be happening at this part. Then here is the network part. A controller like Arduino, if you're using Arduino now, you need to have a Wi-Fi module that will help you pick the signal from the Arduino using this ESP. This is ESP now, Wi-Fi module. This module here will help you pick the signal from the Arduino to the internet. You understand what I'm saying? To the internet. That is if you're using Arduino. And sometimes now, if you are communicating, if the communication is not actually strong, you can connect the Arduino through the UART pin directly to the ESP. And with that, you have to take the information direct to the what? To the internet. Because remember, in your Arduino code now, you're going to have what you call the IP address of the account. That's the IoT platform account you are actually using. Either TeamSpeak, either Blinks, either Firebase, either AWS Azure, or either Google Cloud. So all these platforms now helps you to hold your data. That is actually, they will call them IoT vendors or IoT platform. Then this account here is actually a website mostly, and because it's a website, there must be IP address, there must be gateway, and there must be what? Port number. So all these things now are going to be insert in your code. So with that, through the serial communication, the Wi-Fi module will be able to understand that, okay, you want to communicate with so-so account on the IoT platform. Remember I said earlier that this platform gives us the opportunity to be able to host our device and our project online. So the platform will have all the details that is required. If you're a student with your school account, you can easily have access to most of these platforms, be it TeamSpeak, be it Blink, be it Firebase, and other vendors. And depending on the kind of project you are running, that will determine which type of this platform you are going to work with. So the most important thing that is here, we have the sensors and actuators, we have the controller, we have the Wi-Fi module that will be able to communicate to the internet using these details. Then here we now have the user interface. So that's the most important thing there. And coming down here now, not to waste most of our time, these are different controllers that you can use for any IoT project as a beginner. The first one is the Arduino that I've explained earlier. The second one is the ESP32. You can use ESP32, that's the STM series, this STMF series. You can use Node MCU. Node MCU now have advantage of having both the Wi-Fi module and the microcontroller together on the board. So if you're using Node MCU, no stress. But if you're using Arduino now, you need to have a Wi-Fi module. And if you're using the Wi-Fi module now, you can flash it directly by connecting it to the Arduino board direct, or you can use the adapter. This adapter here, you fix it like this, and you are there. With this, you'll be able to flash your ESP and be able to write program also on the ESP as it may require. And going further again, we have the this is Walnut Pi W, Walnut Pi W, for mostly for IoT based device. Walnut Pi W is a very good guy. We also have another one here again. We call it, that is the RP2040. It's also a very good guy that we can use for IoT based device. And depending on the kind of functionality you want, we also have the ESP32, as I showed you earlier, and also ESP32 CAM. So all these are devices that we, or component or controllers that we can use whenever we are dealing with IoT. Then also, if you have some processing that has to do with image processing, this Raspberry Pi 4 with the Raspberry Pi camera, we also use them a lot to do a lot of projects as time progresses. We also have the Wemo. Wemo also can be used, Wemo D1. You can also use Wemo D1 to do your IoT project. So now, from now henceforth now, we're going to be looking at different projects, different IoT-based projects that are going to be using all these devices to play with. Since that is what we are actually running with our recent cohort. So most of our projects are going to be IoT-based projects. Then going further, small, aside this, the next thing will now be the application of IoT. We all know we have smart cities, we have smart car, we have autonomous vehicles, we have that is precision farming in agriculture now. We have precision farming. We're going to be working with drones and other device for spraying, for weeding, and a lot of that. So aside this basic introduction, I'm sure we are now clear that the basic concept behind IoT now is the device itself, that's the controller, then the sensor and actuators, then the Wi-Fi, that's the connectivity, then the network. Because most time if you're working on IoT device now, you need to have a network dedicated for this. Because the Wi-Fi module will be able to connect to your network. Either connect to your network using your hotspot. So basically what you do, you have a place for username, then you put the username, then again a place for what? For password. Though most time the password is actually something that we can do away with, and you can make, but the username is actually very, very important because it has to know which network is it connecting to. That's what we're going to do on this part. So if your building have a network or your company have a network, there is no stress. Just put the company network name and the company password. Then with that, it's will be able to work fine. And if your company doesn't have this, then you can use your phone. So most time we use phone for demonstration. You allow the Wi-Fi to connect to your phone. And once you on it, if you connect, you are going to see ESP there as the name of the device. Then the next thing now is the vendors. And once you come to the vendors, it's very easy. You're going to create an account with the vendor. You are going to create a channel for the project. Then you are going to put all the fields that you're actually working with. Are you actually doing automation and control, or are you doing control alone? In some projects, you're going to be doing automation, like if you are doing normal, maybe environmental parameter monitoring system, they are going to be having your DHT11, they are going to have your BMP 180 or 182. They are also going to have maybe like your LDR. They are also going to have maybe, let's say, maybe like your gas, maybe like MQ for the air quality. Then maybe you are going to have the rain sensor there, rain sensor. Then maybe last, maybe like a soil moisture. So with this now, you're going to have all these parameters now. These are going to be sensor based. This temperature and humidity, this atmospheric pressure, cloud cover, and altitude. This one will sense the light intensity. That's the intensity of the environment you're actually working on. Then this one, the air quality, MQ135, all those one, MQ3, MQ2, help you to get the air quality of the environment. Then here the rain sensor. Then here the soil moisture content. So with all this now, you're going to be sending all these devices now to your microcontroller, be it STM, be it Arduino, that's the Atmega, be it Raspberry Pi. So from there now, they are now going to be communicating with your via your Wi-Fi module to where? To the internet. Are you getting it? So as time goes on now, we are going to be running projects with all these devices one after the other, so that you're going to be seeing how this thing works without stress. I know IoT is very challenging and it's very lengthy journey, especially when you start working with the lightweight cryptography, when you start working with the IP-based protocol, when you start working with other communication protocols that are actually very, very strong. like the Raspberry Pi now. When you start working with the Raspberry Pi OS, if you are not patient, definitely you are not going to get it. The Raspbian, the Notes, that is the new out of the box OS. Or you're working with the default Raspbian, you are not actually going to find it as easy, as tipsy as expected. But with us here, I'm sure that's going to be very simple, because I'm going to be following it one after the other. Since our latest cohort now are running IoT and embedded system, definitely most of my videos these days is going to be carrying details on how to connect these devices and how to work with them. And all the take-home tips also are going to be shared as expected. Then lastly, as time goes on, too, I want to show you level shifter, because most time the GPIO pins of these devices are 3.3. It's not all of them that have 5-volt enabled GPIO. Like the Arduino now, the GPIO of Arduino is basically 5 volts. You can take in 5 volts, you can give out 5 volts, no issue. But when you come to things like Node MCU, their GPIO is 3.3. It's not 5 volts. So how do you be able to actually play with that? And especially when you're working with the ESP. The ESP GPIO is 3.3 and it's very, very sensitive. So anything above that, you can easily damage it. So I'm going to show you how to shift voltage, either using transistor with capacitor or using a resistor. So thank you for this introductory video. On Wednesday, by His grace, we are going to go live explaining the first project, which is sending data to ThinkSpeak, sending environmental data to ThinkSpeak, and sending the same data to Blinks, to Firebase, and other IoT platforms on Wednesday. We are going to go live from 10 a.m. to 12 a.m. Another live again from 2 a.m. to 4 p.m. So if you are available, you can join us. And if you are not, we are going to drop a detailed video on our TikTok account, Nasir Abdusalam or Nas Consult Embedded, as well as on this our TikTok and other social media platforms. Thank you for joining us. You guys are doing well, and we are appreciating you. God bless the day, and God bless Nigeria. Boom.